Hi, everyone. I hope you're doing well out there. I'm Kjell Anderson, an architect, principal and the director of sustainable design at LMN Architects in Seattle. I'm a big fan of you all. I even wrote a book from an architect's perspective on making better decisions based on working with energy analysts. I love this photo because it shows a high quality of light based on daylight simulation paired with design ideas. Pairing design with data is common in other fields, but in our industry it lags. If you look at the top 10 grossing movies of the 2010s, nearly all of them are about superheroes, and I'm including Jedis in that mix. You are the superheroes when it comes to buildings and climate change. While architects work at reducing energy use and embodied carbon, we are tasked with many, many other things. You get to focus on energy and carbon, and we need your superhero powers of data and information applied to the buildings we design together. Those of you who have attempted to navigate the early design process know it's messy. Providing data that is timed to influence the design is really tricky. When we get the right information at the right time, we can reduce energy use for little or no cost by making better decisions. Nearly all of our clients now have climate goals, and all we need to do is connect their aspirations to sound data and a pathway to achieve them. Now, one of your superpowers is, unfortunately, invisibility, and we need to change that. So here are my 5 tips. First, we don't get to talk to you if we don't have a scope for services. So you have a value proposition is important. Second, early energy modeling only influences the design when we have regular meetings. We also need to make sure that you and we are asking the most impactful questions about performance, collaborating on modeling inputs, and getting feedback that is timed to influence the messy design process. And then finally, remember that architects like books with pictures. We don't enjoy reading long reports. We want clear, summarizing graphics, backed up by you telling us or answering any questions that we have. Now, owners want to know what they're getting, and ASHRAE 209 helps. We use it in energy modeling RFPs to clarify early energy modeling purposes and terminology. My favorite part is that it requires the energy analyst to be invited to an energy charrette. Not only that they are a person, but also an important part of the team. Even when we have energy modeling scope, I've seen interactions fail. Early energy modeling is not used, or it's used too late, or it's not coordinated well enough, or the analyst isn't facile in working with architects yet. I found biweekly meetings in early design keep the energy and carbon top of mind for the design team. At meetings, get the design team to ask their performance-related questions. Explain answers to the design team, but keep your comments to 3 minutes to leave space for discussion, especially in this remote era. Confirm the most important energy modeling inputs with the team, especially schedules. LMN uses a document to track envelope parameters and design team questions. This goes back and forth several times between the architect and energy analyst to help keep us on track. Now, our clients often fall in love with an early design, making it difficult to change anything later. So we need early feedback. We don't need accuracy to the 5th decimal place. We want relative comparison. We need you to be able to provide a time estimate for various models. Perhaps there's an optimized way to answer the questions that doesn't even require a detailed model. Your experience on other projects, for example. Lastly, we need you to pull out the most relevant information from your explorations. This can be based on the questions we've asked together, or some interesting conclusion you've discovered, or an option that hasn't even been thought of yet. To help me ground myself when I'm presenting energy modeling results, I imagine myself attending an accounting conference, and I don't know what the charts are supposed to be showing. I have no idea what this chart means. And I'm guessing that you don't either. Can the acronym be made into plain English? Can the text be bigger? Can a few of the most important points or trends be pointed out somehow? Technical charts are necessary, but remember that architects that you send this report to will have to present the same chart to the building owner. If they don't understand it, they won't present it to the building owner. You can check out Project Stasio for some graphic examples of how to present complex data. So in this example project, we put ASHRAE 209 in the energy analysis RFP cycles 1 through 7. Early analysis was presented to the entire design team, which suggested separating the building into 2 bars so we could use different mechanical systems. We were also able to convince the university not to connect to their steam system, meaning we'd only use the low carbon electricity we have in Seattle. All of these decisions were made based on timely interactions and data from our superhero energy analysts in the earliest design phases. In fact, electrification is one of the biggest impacts we can make on projects. Showing the value of heat pump water heating and space heating and not using gas means we can take advantage of the fact that the grid in most places in the US is actually trending towards zero carbon electricity by 2050. So we also consider the embodied carbon. That's a really important part of our studies now. Mass timber helped us with this one. But actually the embodied carbon of a mechanical system is significant. We can reduce the size or complexity of a mechanical system. We can have huge embodied carbon savings. And with that, my 5 minutes is up. Thanks everybody, stay healthy.